Hello everyone, we are back and we are going to be looking at grain boundaries, external surfaces, and basically 2D defects. There are lots of different types of 2D defects. Grain boundaries are going to be the ones that we're going to talk about the most. So grain boundaries are effectively in crystalline materials and non-crystalline materials somewhat, and other materials. But basically, these red lines here are boundaries from where a crystal has a certain orientation, like this, and then it switches to a different orientation. You can kind of see all the different angles and orientations here. So those grain boundaries are important because the size of those grain boundaries, as you figured out in that first problem set with nanocrystalline materials, they change essentially the mechanical properties. So grain boundaries are a big one that we're going to focus on in this course when it comes to mechanical properties. Phase boundaries, if we have multi-phase materials and different phases exist on each side, twins are very important. So twin boundary or twin defects basically occur a lot in when you have shear stresses or annealing. And you can also have these stacking fault energies or stacking fault defects. So for HCP, if you stack AB, 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 or FCC, which is ABC, you can have, if you're missing a layer, so ABC, and then there needs to be an A, that's an intrinsic defect. If there's an extra layer added, that'd be an extrinsic defect. And this is really important in the automotive industry when you're developing metals to control yield strength properties as well. Additionally, you can have anti-phase boundaries. So when you have different regions and there's a different phase, beta phase or something like that in your material, you can have those anti-phase boundaries. And then finally, bulk or volume defects, pores, cracks, foreign inclusions, other phases. Those are kind of your 3D defects. So that is all we have for defects. So we will see you all in the next video. Thanks. Bye.